All right, you should be in your textbook on page 181, section 4.5. Okay, so in example 1, I'm comparing fractions. I'm comparing 7/10 to 3/4. Well, the problem is I can't compare fractions that are not the same size. And when I'm talking about the same size, I'm talking about the denominators. The denominators have to be the same size. Basically, these numbers tell me how many times the fraction is divided into, or the whole is divided into pieces. All right, so I have 10 pieces in one fraction and 4 pieces in another fraction. So here's the trick, okay? And most of you are to the point now where you can do this mental math, and I'm not concerned about you showing work, all right? Are you going to complain about it? Is that a problem that you don't have to show work? Of course not, okay? Now, if you need to, then just write it off to the side. But we're going to start with the largest denominator of the two, which is 10. We're going to start counting multiples until we get to a number that 4 can go evenly into. What, does 4 go evenly into 10? No. What about 20? Yes, it does. So 20 is my LCD. Okay, so I'm going to write 20 directly underneath the original fractions. All right, now I need to figure out what number goes in my numerator. I can't just bring it down from my old fraction. I have to figure out, what did I multiply 10 by to get to 20? 2. So I do want you to show that step. Okay, right here, just say multiply by 2. And then whatever I multiply the bottom by, I have to multiply the top by the same thing. So 7 times 2 is 14. All right, same thing over here. 4 times what gave me 20? 5. So 3 times 5 is 15. And now I can compare them. So now I can look at my numerators and what sign belongs in my blank. A less than sign, less than. And less than is my answer. All right, so now let's do another one. Okay, I want you to work on 5/8 compared to 7/12. Okay, and tell me less than, greater than, or equal to. All right, so Jonathan, what did you get for your LCD? What did you get for your LCD? Well, what number did you get for your LCD? Larry? 24. Very good. Okay, 24 is my new LCD. Okay, and what number did I write in my numerator on my first fraction? 15. Very good. And what number in my second fraction? 14. So what sign belongs in the blank? Greater than. Perfect. Who got it right? Awesome. Good job. All right, now in example 2... Okay, now in example 2, now I'm basically doing what I did in example 1, except with multiple fractions. Okay, so I have 2/3, 3/8, 1/6, and 3/4. What is my problem? What's my problem? They're not the same size, okay? So what I need to do is start with the largest denominator and start listing my multiples until I get to a number that they all can go into. Well, do they all go into 8? No, because 3 doesn't go into 8. So what's the next multiple? I know you know. Just hang on. 16. But does 3 go into 16? No. Okay. What's the next multiple? 24. Does 3 go into 24? Does 6 go into 24? Does 4 go into 24? So 24 is my LCD. Okay. You can, if you're having trouble visualizing this, off to the side, you can choose your largest denominator and just start listing your multiples off to the side. Maybe visually it might be easier to see that way, and that's perfectly fine. If you can do it mental math, that's fine as well. You don't have to show your work for finding the LCD. Okay, so now how do I figure out what my numerators are going to be? Peyton?
You would see how, like, for 2/3, you would go how many times those 3 go into 24.
Very good. Which is how many?
8, and 8 times 2.
Okay, perfect. So on my second fraction, what am I going to multiply by? Class? 3. On my third fraction, what am I going to multiply by? 4. And on my fourth fraction, 6. Very good. So now go ahead and multiply these out and write your new numerators. All right, so let's go through them. What's my first fraction? It's going to be 16 over 24, 9 over 24, 4 over 24, and 18 over 24. Okay, so now that I'm comparing, everybody agree these are all the same size? Okay, now that I'm comparing same size, I can look at my numerators and see which number is smaller. And which number is the smallest? It's going to be the 4. So in my answer, I'm going to write it as its original fraction. That's why I wrote it directly underneath, so it's easy to see what it was in its original form. And I'm going to write 1/6. Okay? Now what's my next smallest fraction? 3/8. Okay? Do you understand why I wrote 3/8? Because it was 9/24. Okay? And its original form was 3/8. You see that? Okay? So now what about my next fraction?
2/3.
And then my last one.
3/4.
All right, and I'm done. All right, so let's recap real quick. This is my original problem. This is my work shown. I have to make them all the same size so I can compare. And this is my final answer. I wrote the fractions in their original form in my final answer. All right, so now I want to do your turn now. Numbers 2 and 6. Your turn now, numbers 2 and 6 on page 182. Okay, so what was your common denominator for number 2? Just tell me. 30. 30, very good. So comparing 25 to 27, less than. Who got that right? Less than. Raise your hand if you got it. Hello? Raise your hand if you got it. Okay, number 6, what was my LCD?
48.
It was 48. So do I even do anything with my first fraction? No, I'm just going to bring it down and rewrite it. Okay, what's going to be my second fraction?
24.
24/48. What's going to be my third fraction?
8/48.
8/48. What's going to be my last fraction? 20/48. Now I can compare, and remember, in my answer, I write the fraction in simplest form. 5/48, then what comes next? 1/6, then what comes next? 1/2, then what? 7/12. All right, who got that one right? Number 6, raise them high. Okay, good, good. All right, any questions on these problems? Any questions? All right, so now moving on to example 3. In example 3, we're going to compare fractions using approximation. All right, so I have 13/24 and 15/34. 13/24 and 15/34. Okay, and what I'm going to do with these fractions, approximation, does that mean that I'm going to find an exact answer?
No.
Okay, so what I'm going to do with these is I'm going to compare them to 1/2. All right, what is half of 24? 12. So I would say that 13/24 is greater than half. Would you agree? It's more than half, because you just said that half was 12. Well, 13 is more than 12, right, Bruce? Okay. So, what about 34? What's half of 34? 17. So, 15/34, is that less than or greater than half? It's less than half, because 15 is less than 17. So, if one of my fractions is greater than half, and one of them is less than half, which one's bigger? 13/24, because that's more than half, and 15/34 is less than half. Do you see how I'm comparing it to my halves? Okay, so whenever you're comparing these using approximation, you're going to compare them using the baseline of half. Is it more than half or less than half? Sometimes on the tougher ones, they're both going to be, say, less than half, but one of them is going to be less than half by more, if that makes sense. Okay, so you just have to look at which one is closer. All right, so let's look at number 33 on page 184. Page 184, let's do another one of these. I'm sorry, number 31. Let's do number 31. Number 31 says 19/30. You do have a section of these on your homework tonight. And 16/33. So I want you to use your principle of halves, just like what I just taught you, to try to figure out which one is what belongs in the blank. Greater than, less than, or equal to. All right, so now let's compare it again using our principle of halves. Okay, so 30, what's half of 30? 15. So 19 over 30, is that greater than or less than half? It's greater than half, right? Because 15 is half. Well, 19 is more, right? So 19 over 30 is greater than half. What about 16 over 33? That's just barely less than half. But it's still significant. So what sign belongs in the blank? Greater than. 19 over 30 is greater than. Okay? One was greater than half. The other one was less than half. All right, and if you understand that, that's everything you need to know for 4.5.